This is how we can bias transistor to act as a signal amplifier or switch. Uh, this is a very important characteristic of how we can explain this thing. This is called transfer characteristic for NPN transistor. As you can see, there are main three regions for the transfer characteristic. When we changing the base current, how the collector current behave. So we can see that the smaller values of base current, IB is very small, in the collector current as also very small. But after some specific IB value, the base current, while we increasing the base current, collector current also increasing as a linear. So we call that active region or linear region. After some higher IB value, what will happen? The collector current reach to its maximum value and saturated. It will not change after reaching this value. So we call these regions as cutoff region, active region and saturated region. When we use transistor in a signal amplifier, we should bias it to the active region. So in the signal amplifier, transistor should functioning in the active region. When it is functioning as a switch, it should be in the saturated and cutoff region. We have to switch it in between these two regions, because saturated region it act as an on switch, in cutoff region it act as an off switch. So how can we bias this NPN transistor to active region? When we bias it to the active region, we have to provide VBE voltage as 0.7. I'm talking about the silicon NPN transistor. So we have to forward bias the base emitter junction by giving 0.7 voltage and reverse biasing the BC junction. Reverse bias BC junction. This is how we can bias the transistor into the active region. For the saturated and cutoff regions, for the cutoff region, if we supply VBE value smaller than 0.7, automatically it will goes to the cutoff region, as because when we supply in the lower VB value in input characteristic, it shows that how the IB current vary with the voltage. So it is curve like this. This is the 0.7 for the silicon transistor. So if the VB value lower than 0.7, we can see that the base current is very small. So very little base current means collector current also is a very low according to the transfer characteristic. So we can say that when the VB is lower than 0.7, automatically this transistor turn into a cutoff region. What about the saturated region? To transistor act in saturated region, we have to provide VBE much greater than not much greater than we so how can we bias this transistor saturated region? We have to provide VBE value greater than 0.7. It's something like 0.1 volt or something. We cannot say exactly what is the value, but if we provide VB value higher than 0.7, as you can see, according to the input characteristic, there is a high IB current. So high IB current means it may in the saturated region, right? So that is how we can bias transistors into these different three regions, and we can use it as a signal amplifier switch as we need.